Hi, I'm Zoe.
I'm James.
I'm Nina.
Today we're going to be talking about lake fires or algal blooms. So picture this. It's 2012. It's the middle of a gross July month in Cranberry, New Jersey. And it's like 85 degrees, but it feels like over 9,000. And worst of all, your local pool shuts down because it's become engulfed in this gross green sludge.
Nasty.
So what is this sludge? And why is there so much of it? It's algae. Most of us are familiar with the small photosynthesizing microorganism that gives lake water that tinted green color. And as we learned in this module, algae of all kinds are limited by certain nutrients depending on their specific needs. In the case of the 2012 cranberry algae catastrophe, a fertilizer containing nitrogen accidentally leaked into the pool, causing algae to grow out of control.
So what is a limiting nutrient?
Well, you can think of a limiting nutrient like the bacon at a breakfast buffet. As we all know, bacon is the most delicious part of any breakfast buffet, making it the primary limiting nutrient. As more and more people pass through the breakfast buffet, the bacon supply depletes rapidly because basically everyone is taking some. At some point, there will be no more bacon left, and the lack of bacon, the limiting nutrient, will limit the amount of people returning to the breakfast buffet.
Algae use sugars, not bacon, to obtain energy, so the sugar-producing capabilities of algae are generally limited by nutrients like nitrogen, phosphorus, and iron.
Limiting nutrients are defined as the nutrients that become scarce as the population size increases. Once these nutrients become scarce, the population size cannot grow any further. As demonstrated by the principle of Liebig's barrel, the shortest side of the barrel limits its population capacity. We learned about two types of limiting nutrients: primary limiting nutrients and secondary limiting nutrients. The primary limiting nutrient is the first nutrient that restricts the population size. If the primary limiting nutrient is in excess, the secondary limiting nutrient is the next limiting nutrient that restricts the population size.
So what would happen if these limiting nutrients suddenly weren't so limited? Let's take a look. So this is a video of an algal bloom or a lake fire in Utah Lake.
Lake fire? That sounds pretty epic.
Sounds pretty epic, but it's actually not. Algal blooms look really cool, but they can be toxic. They've been shown to generate a number of harmful compounds. The CDC warns that in high enough amounts, these toxins can cause rashes, digestive problems, and for certain individuals, serious allergic reactions. If you don't like looking at gross medical photos, you can avert your eyes to this next one.
Gross medical photos.
Lovely.
So as you can see, algae is no joke. Fortunately, we already have a good idea of why phenomena like lake fires occur. For most blooms of algae, an abundance of phosphorus and nitrogen is the culprit. Because of human overuse of fertilizers, huge amounts of phosphorus and nitrogen have found their way into lakes and streams.
The excess of nutrients in the water triggers massive algal blooms, and as the algae die, their decomposition by microorganisms takes up the dissolved oxygen in the water, and the layer of algal bloom prevents new oxygen from being dissolved and sunlight from entering.
This phenomenon is known as eutrophication, and has caused many fish populations to decline in many lakes and rivers. Eutrophication is a huge problem in freshwater ecosystems, so it's important that we understand the underlying mechanisms behind it.
And this can happen in oceans too. Blooms of algae can completely overwhelm marine ecosystems just like they can in lakes. Since liquid water covers the vast majority of our Earth, this potentially could be a bigger problem than we even realize.
So what can we do to understand the mechanisms of algal growth?
Well, a lot of us have tried altering algal growth with a lot of different things, from hand sanitizer to Tide Pods to vitamins. Exactly how algae is limited by various compounds is uncertain. So experimenting with some of these ridiculous items is not as ridiculous as it seems. For all we know, the solutions to the problems could be lying around in our own homes.
And besides preventing eutrophication, there are many other beneficial reasons for experimenting with limiting nutrients, namely renewable biofuel production. Since algae store their photosynthetic products as lipids, species like those used in our experiments, Chlamydomonas reinhardti and Enchistodermis falcatus, can be farmed to produce biofuels. Many of our experiments were focused on augmenting the growth of these algae by altering the available nutrients. From these results, a more sustainable and efficient method of farming algae can be designed. As we learned from our climate change forum, sources of renewable energy are absolutely necessary for our continued survival.
Both the issues of sustainable biofuel production and eutrophication are extremely important and affect our environment and our everyday lives. Let's watch James provide a brief demonstration of what our government is doing about this right now.
You can see the research is being done, but we need a bigger push. And our experiments might not seem like they had a giant impact, but for someone in this room, they could be the start of something much bigger. It really is on us to find sustainable solutions to fuel our future. Thank you.